So we spent some time talking about Pascal's triangle and how it relates to the coefficients in a binomial expansion. Okay, so that's option number one, as to expand a binomial or raise a binomial to a power. But depending on your exponents, you may not always want to use Pascal's triangle. Okay, so our second option is what's called the binomial theorem. And it's a way of defining the different coefficients in a binomial when you're expanding it. Now, for the first two terms in any expansion, we really shouldn't have to think about Pascal's triangle because remember, every coefficient or every expansion starts with a coefficient of 1, and then our first term is being raised to the biggest power. So it's 1x to the nth, okay? Second term always uses that n as its coefficient. The exponent starts decreasing on the first term, so it was n, now it's n minus 1, and increasing on the second, so now it's to the first, always giving you a total of n with your two exponents. Okay, but now I'm not sure what that third term is going to be, and it really depends on that value of n. I'm going to skip my coefficient for just a sec and come back to it. The exponent on the first term is going to keep decreasing. So it went from n to n minus 1, now it's n minus 2. Second exponent keeps increasing. It was 0, now 1, now 2, seeing that total of n when we add them together. Okay, now jumping to the front, I'm going to write it like this. The top number, and this is going to look like a fraction for a second, but I'll explain it. The top number is always going to be n, which is your biggest exponent. The bottom number can either actually be whatever your first exponent is or your second. I typically put in the second. Okay. Now this is, again, is not a fraction. It's representing what we call a combination. Like you have 5 items and you're choosing 3 of them. How many could you choose? Another way of writing it is NC2. Okay. And this actually is defined using factorials. So it's n factorial divided by the second number factorial and then the difference of those two numbers factorial, which if you notice is the exact same as our exponents. Okay. So this is something we'll be able to type in the calculator, and I'll show you that when we get to this application. But that's really what it's defined as. Okay, so let's get back to our expansion. Again, I'm going to skip over my coefficient for just a sec. The exponent on the n is going to continue to decrease. So it's n minus 3. Exponent on the y is now going to increase. It is 3. And I can come to my combination. N is always in the numerator, and either of those goes to the bottom. Okay, so again, we would just continue that pattern on until we run out of terms. So this is called our binomial theorem. All right, so let's go ahead and apply it. I would like to go ahead and find the first 5 terms of x plus y to the 23rd. Now, if you don't remember this the binomial theorem, you could always write out 23 rows of Pascal's triangle. Hopefully, you'll remember this pattern instead. Okay, so let's think first term. We know coefficient starts with 1. It's going to be the first term to the biggest power, 23. First term's taken care of. Second one, 23 becomes my coefficient. It is now going to decrease to 22 as an exponent on x, and y comes in with a 1. So you can see the total of 23. Okay, plus. Now I'm to the point where I don't know what my coefficient's going to be. So I'm going to apply my binomial theorem. Okay, I'm going to skip my coefficient. X exponent decreases, 21. Y increases, it is 2. And then my combination would be 23 as my biggest exponent, my n, and then either 21 or 2 on the bottom. Again, it does not matter. Okay, I'm going to go ahead and finish up my expansion, and then we'll come back and simplify and find that actual number. So x goes to 20, y goes to 3. Combination out front, always n on top. I'm going to go with 3 on bottom. And that's 1, 2, 3. That's 4 terms, so one more. X is now 19, y is 4, and I've got 23 and 4. Okay, so there's my first 5 terms of this expansion. Now I need to go back and clean up my coefficients. I need to know what 23C2 is, 23C3, and 23C4. So I'm going to go to my calculator. Okay, to find this on your calculator, you're going to go to your math menu and then over to probability. If you have one of the older ones, it just says PRB right there. But you can see on the third line down is NCR, and that's what we're using for our combinations. Okay. On this calculator, it'll show up like this. Again, if you have an older one, type in the first number first before you go to that menu, and it'll pull that in as your first value. Okay, so the first time I needed it was for 23C2. So I'm going to type in my 23. I'm going to arrow over and type in my 2. It's going to apply the factorials for me, and it tells me that that value is actually 253. Okay, and now I can move on to the next one, 23C3. So math, ERB, NCR, I need 23C3, and I get 1771. Oops. And then last but not least, 23C4. So math, ERB, NCR, 23C, and that is 8,855. So I now have my first 5 terms. Okay, let's try another one. Let's find the first 5 terms of 2x minus 3y to the 8th. Okay, so again, just applying our same pattern. I know the first coefficient is going to be 1. It's going to be my first term. Now, this is a little tricky. First term isn't just x, it's 2x. So it's 2x to the 8th. Okay, so when we go back and clean this up, we're going to have to also raise 2 to the 8th, and then no y's. Okay, plus coefficient becomes that big exponent, which is 8. 2x is now raised to the 7th, and the y comes in. But again, it's not just y, it's actually negative 3y, which is being raised to the first. Okay, moving on, I'm going to skip my coefficient. I'm going to just do my exponents first. So 2x is now to the 6th. Negative 3y is being raised to the 2nd. There's my total of 8. My combination would be 8, and I'm going to choose C2. Okay, plus, skipping my combination, I now have 2x to the 5th, negative 3y to the 3rd, and then I can go back and do 8C3. And I'm running out of room, so I'm going to let you fill in the rest. Now I'm going to come back and clean these up. Remember, anything in the parentheses has to be raised to that exponent. So I'm going to go here, this over here, and I'm going to keep it on top. So I need to know, for the first term, what is 2 to the 8th? 256. Okay, so the first term in this expansion is actually 256x to the 8th. Okay, next term. I'm going to go ahead and do this all in one step. So I have 8 out front, multiplying that with 2 to the 7th, and then again with negative 3 to the first. So that's telling me negative 3,072 is my second coefficient, and that is x to the 7th, y to the first. Okay, next one, I have my 8C2, so math, ERB, CR, so 8C2, and I can continue on with my x and y exponents. So times 2 to the 6th, oops, except I put minus, make it times, and then times negative 3y squared should give me 16,128. Right? So plus 16,128 x to the 6th y squared. And then for the last one that I wrote down, I have 8C3. So 8C3 times 2 to the 5th. Oops, get out of that exponent, times negative 3 to the 3rd. And I'm seeing a final final coefficient there of negative 48,384 x to the 5th y cubed. And then that would continue on. Okay, so make sure you go back and do those final simplifying. Okay, and I can see my 4 terms. You should have 5. Now, what if I just want to find a specific term? Okay, so keep in mind your pattern. The first term doesn't have any y's. Second term has 1 y. Third term has 2. So this second exponent always ends up being whatever term minus 1. Okay, so I'm going to build this backwards. 3y to the 9 minus 1. X. My total is 45, and I've got 8 here. This is 37. And then this guy can be 45. And then you would do your simplifying from there. Again, don't leave it like this. Come up with a final answer, whatever it is.